Welcome to Maths. This is Semangea, the Maths Eagle. Right. This video is all about statistics one based on probability. Probability, mainly combined events, mutually exclusive events, exhaustive events, and independent events. These are the things that you are going to learn in this video. Then after watching, please like, share, and subscribe to this nice, powerful video. Semangea the Eagle signing in. Let's get started. Alright, so the first part is based on explanations. What are combined events, mutually exclusive events, exhaustive events, independent events? I start with combined events. What are these called combined events, right? Two events are said to be combined if they have something in common. These events can happen or occur at the same time. For example, we can have events A and B. Like events, for example, let me use playing cards. There are 52 cards in a pack of that playing cards, right? If a card is picked at random, then can you find the probability that the card is it's a spade or queen? Spade or queen, right? You find out that there is a card that is a spade, and this same card is also a queen. These are combined events, right? So based on combined events, they have intersection like this. You have event A and event B, so they have something that is in common. So if we can break down this probability based on the law of addition, this one will be probability of spade plus probability of queen. If we can say, for example, let me work out this one. How many spades are in that pack? There are actually 13 spades over 52 in total playing cards, plus queen is 4 over 52. But in this case, we have a card that we have counted twice. This one is a queen of spades. Take note. So that queen of spades, we have counted it on spades and also on queens. So this one is the card that is found in both sides. That's the card that is in common, both queens and spades. So you have to subtract one of them, 1 over 52, then to get the actual probability, in this case over 52. Let me finish up this one. 13 plus 4 is 17, minus 1 is 16. Then after that, you can simplify this one, your answer is a, and write down your answer. So in this case, we find out that if we can write probability of A or queen, or it means union. Take note. So A union B is equals to probability of A plus probability of B minus probability of A intersection B. A intersection B, these are the things that are found in both A and B. Like in this case, a queen or spade is found in both spades and queens. So we have to subtract one queen, subtract the intersection. That's all about combined events, right? That's about combined events. Then if you can want to calculate probability of A intersection B, is just making probability of A intersection B subject of formula in this case. It means this one, union, will come this side and you have to subtract it, right? So it will be minus probability of A union B. Next, mutually exclusive events. That's number 2. Mutually exclusive events. What are these mutually exclusive events? Right, these are events that cannot happen at the same time. If they cannot happen at the same time, then they have no intersection. They have nothing in common. Like in this case, we can have A and B. These are two events. You can see they don't have any intersection. Intersection like this, intersection A intersection B, it means there's something in common on both A and B. But these events, they don't have anything in common. They cannot happen at the same time. which means probability of A intersection B is supposed to be 0 because there's nothing on mutually exclusive events. Take note of that. So if it's 0, if we can write down, for example, probability of A union B, we said based on combined events is probability of A plus probability of B minus probability of A intersection B. Since these events, they don't have intersection in 0, this on mutually exclusive events, probability of A union B will just become probability of A plus probability of B, like this. That's probability of A union B. Intersection not available. Right, next, exhaustive events. Exhaustive events, these are events that complete the whole set. For example, we can have like this: event A and B, they form the universal set, so they complete everything that is in the universal set is in A and in B. There's nothing outside set A and set B. That these are called exhaustive events. This means that probability of A union B is supposed to be 1, or probability of A or B is equals to 1. Union means all. So A and B makes up the universal set. Then number 4, independent events. Independent events are events that whose occurrence of one does not affect the occurrence of another. These events, they don't affect one another. These are called independent events, right? So the event A can happen at the same time event B happening. Event A does not affect the occurrence of event B. These are called independent events. So if two events are said to be independent, probability of A intersection B is equal to probability of A times probability of B. Then probability of A union B is equal to probability of A plus probability of B. So they don't affect each other. These are called independent events. Right. Now, questions. Question number 1. In a class of 20 children, 4 of the 9 boys and 3 of the 11 girls are in the athletics team. A person from the class is chosen to be in the egg and spoon race on sports day. Find the probability that the person chosen is in the athletics team. In a class of 20 children, 4 of the 9 boys and 3 of the 11 girls are in the athletics team. How many altogether are in the athletics team? We have 4 boys plus 3 girls. So there are 7 out of 20. Then a person from the class is chosen to be in the egg and spoon race on sports day. Find the probability that the person chosen is in the athletics team. So you just have to check how many of the students or children are in the athletics team. It's 4 boys plus 3 girls. It will be 7. So probability of athletics team is equals to 4 plus 3 over 20 altogether, which is equal to 7 over 20. That's first part. Then part number B, female. The probability that the child in this case is female. Probability of female is equals to, just count how many females do we have. We have 11 girls. These are females. It will be 11 over 20 children. Done. Next, part C, a female member of the athletics team. So what is the probability of choosing, of a person chosen is a female member of the athletics team, right? How many are female members of the athletics team? We have 3, right? So you have 3 female members. That's part C. It's 3 over 20 children altogether. Then done. It's actually easy, right? Then number D, a female or in the athletics team. Is a female or in the athletics team. Right? You have to apply formulas here. Probability of female, let me use F for female and A for athletics team, or it means union in the athletics team. So this one, breaking it down, is probability of, and take note, these are combined events, because you can have a female who is in the athletics team, like there are 3 females, girls in the athletics team. These are combined events. So probability of F union A is equals to probability of F plus probability of A minus probability of F intersection A. That is a female member of the athletics team. Right, first part, female is 11 over 20. That 20 females plus probability of athletics team, you found it per part A, is 7 over 20 minus probability of female in the athletics team. You found it here. 3 girls in the athletics team is 3 over 20. Like this. Then, if we can add over 20 here, 11 plus 7 minus 3. 11 plus 7 is 18. 18 minus 3 is 15. Which is 3/4 or 0.75. Then we can say done. Next question. Question number 2. Right, these are tables. Tests are carried out on 3 machines A, B, and C to assess the likelihood that each machine will produce a fault component. The results are summarized in the table. A component is chosen at random from those tested. Find the probability that the component chosen is from machine A. Right, first thing first, you have to put totals. Put totals first. Total here, total column, and even total down here. Total column, total 3 plus 2 plus 5. 3 plus is 10 here. Then 12 plus 8 plus 15. 12 plus 8 is 20. 20 plus 15 is 35. Then totals on this side. Then they make a total on this part here. Right. On this side, 3 plus 12 is 15. That's the total. Then 2 plus 8 is 10. 5 plus 15 is 20. Then 15 plus 10 plus 20 is actually 45. The total must be the same as on the horizontal side. Vertical total must be the same as horizontal total. 10 plus 35 is to get 45, right? Then we start answering our questions now after writing down the totals. Find the probability that the component chosen is part A is from machine A. Right? You just check machine A. How many components are in machine A? We have fault components and not fault components. Those are both components in machine A. So fault is 3 plus 12 fault components. 3 plus 12 is 15. Yeah? Over total number of components altogether. So it will be 15 over 45. Probability of machine A is equals to 15 over 45. This one simplified, you can use your calculator. 15 divided by 45, you get 1/3, 1 over 3. Right, done. Next, question number 2, item 2. Find the probability that the component chosen is a fault component from machine C. Fault component from machine C. Where is machine C here? It's here. Fault component is 5. Right? So there are 5 components in machine C which are, that are faulty. So it's 5 over total number of components altogether. This one will be 5 over total number is 45. It will be 1 over 9. Then you can say done. Next, item number 3. This one, A, item 3, is not faulty or is from machine A. Is not faulty or is from machine A. Right, this one, you write it like probability is not faulty, which means not faulty bar, F bar is not faulty or from machine A. So F bar means not faulty and machine A. So you say probability of not faulty plus probability of machine A minus probability of not faulty and machine A. Intersection machine A. It will be probability of not faulty. Not faulty is what? We can say 12 is 35, the total here. 35 over 45. 35 over 45 plus probability of machine A. Machine A is 3 plus 12 is 15 over 45. 15 over 45 minus not 40, and from machine A is actually 12 over 45. 12 over 45. Right, then you simplify, it will be equals to, maintain your denominator 45, is 35 plus 15. 35 plus 15 is 50. 50 minus 12 is 38. So it's 38 over 45. Then you can say done. Next part, next question, part B. This one, it is known that the component chosen is faulty. Find the probability that it is from machine B. This one is part of what is known as conditional probability. Don't worry, there's another video that I have done on conditional probability. You can check it on my YouTube channel. It's Laxton Mangea. Right, it's there at my YouTube channel, Laxton Mangea. Right, find the probability that it is from machine B. We are given the condition that this machine or component is faulty, and we are being asked to find the probability that it's supposed to be from machine B. It will be like this: probability of machine B given that it is faulty. So based on the concept or principles of conditional probability, we can say is equal to probability of B intersection F over probability of B. There's a video on this. This one is just giving you that's a light based on this question. Since it's there, let me just work it out. Right, probability of B intersection 40 is from machine B and is 40 is 2, right? So it's 2 over total, which is 45. 2 over 45 divided by, then from machine B, probability of machine B, how many units from machine B is 3. 2 plus 8 is 10 over 45. So it's 10 over 45. Simplifying this one, 2 over 45 times 45 over 10. Then 2, 1, 2, 5, 45, 45. It will be 1 over 5. So it's 1 over 5. That's part B. It's 1 over 5. Then we can say second question done. Next question, question number 3. Right. In a race in which there are no dead hits, the probability that John wins is 0.3, and the probability that Paul wins is 0.2, and the probability that Mark wins is 0.4. Find the probability that John or Mark wins. John or Mark wins. Take note, this one is like someone is supposed to win, right? So it's either John or Paul or Mark. It's not everyone can win at the same time. So these are classified as independent events. These are independent events. So probability that John or Mark wins. Mark or John cannot win at the same time. So you can say probability of John or Mark, J for John, M for Mark, is equal to probability of John plus probability of Mark, which is equal to John is 0.3 plus Mark is 0.4, which is equal to 0.7. That's the final answer there. Then part B, this one was A. John or Paul or Mark wins. These are independent events. John or Paul or Mark wins is probability of John plus probability of Paul plus probability of Mark, which is equals to John is what? 0.3 plus Paul 0.2 plus Mark 0.4. If you can add all these items, you can get 0.9. So that's the probability of John or Paul or Mark wins. Then part C, someone else wins. It means it's not Paul or not John or not Mark. So which means you can just say someone else wins. Someone else here. It means not Paul, not John, or not Paul, or not Mark. In this case, you can just say 1 minus probability that all these John or Paul or Mark wins, right? So it's 1 minus probability of John, Paul, or Mark wins, which is 1 minus 0.9. 1 minus 0.9, 0.1. That's the final probability. Then you can say done. Next question. Question number 4. Events A and B are such that probability of A is 0.3, B is 0.4, probability of A intersection B is 0.1. Find part A, probability of A intersection B complement. Right, this one, A intersection B complement, you need a set. Without a set, it's very difficult to work out questions like this. You have to write, let me draw my set here. We have event A and event B. A and B are like this. Then we are given that probability that of event A is 0.3, which means the whole set of event A is 0.3, then B is 0.4, then intersection 0.1. So always start by the intersection 0.1 here, and set A is 0.3, which means this part is 0.2, is 0.3 minus 0.1. On event B, 0.4, which means B only is 0.4 less 0.1, which is 0.3, like this. Then find probability that probability of A intersection B complement. B complement B1. It means what is outside set B and intersection A and found in A. Outside B and found in A. And in this case, if you can check here, probability of A intersection B complement, what is outside B and found in A is probability of A, which is equals to 0.2. Then next part B, probability of A complement intersection B complement. It means outside A combined with outside B. Outside A combined with outside B is the same as what is not in A and what is not in B and what is not in what is not in these two sets actually. In other words, what is outside these two sets. You suppose say 1 minus, you add A union B, so it's 1 minus probability of A union B. What is in A and in B? 1 minus A union B, 0.2 plus 0.1 plus 0.3, which is equals to 0.2 plus 0.1, 0.3 plus 0.3, 0.6, which is equals to 0.4. That's the final probability. A complement intersection B complement. Right, we can say done. Next, question number 5. The probability that a boy in class 2 is in a football team is 0.4, and the probability that he is in the chess team is 0.5. If the probability that a boy in the class is in both teams is 0.2, find the probability that a boy chosen at random is in the football or chess team. Football or chess team. This one, you can also say probability of football team, F is equal to 0.4. Then probability of chess is 0.5. Probability of both football and chess, both teams is so football and chess is equal to 0.2. Then find probability of F union C. That is O. O means union. You can say probability of F using the law on combined events plus probability of C minus probability of F intersection C, which is equals to F 0.4 plus 0.5 minus 0.2. 0.4 plus 0.5 is 0.9, minus 0.2 is 0.7. Then we can say done. Next question, question number 6. In a group of 60 students, 20 study history, 24 study French, and 8 study both history and French. Are events a student studies history and a student studies French independent? Right? Are they independent? Right? You have to calculate. If two events are independent, then probability of A intersection B must be equal to probability of A times probability of B if they are independent, right? So if they are independent, probability of French, history and French, H and French must be equals to probability of history times probability of French. Like this. Right, 20 study history and 24 study French and 8 study both history and French. Are these two events independent or not? Right, you can say here probability of history is equals to 20 over total is 60. Then probability of French is 8 over 24 study French. So it's 24 over 60. Then 8 study both history and French. Probability of H intersection F is equals to 8 over 60. Like this. Then are events a student studies history and a student studies French independent. Right? We have to calculate probability of A intersection F is this one, 8 over 60. So 8 over 60 must be the same as 20 over 60 times 24 over 60, like this. So they must be the same. Probability of H intersection F must be the same as probability of H times probability of F. Then let's simplify. If you can simplify here, 0, 0, 2 here, 1, 2, 3, 3 here, 3 into 24 is 8, is 8 over 60. So 8 over 60 is equals 8 over 60. So it means the two events are independent. So they must be the same. Exactly. So independent. In probabilities, however, you have to simplify this, right? Don't leave it as 8 over 60. You simplify it to 8 over 60 is 2 over 15, right? So to 2 over 15. So they are the same. Therefore, the events are independent. Then next question number 7. The probability that a certain type of machine will break down in the first month of operation is 0.1. It will break down 0.1. It's either it will break down or will not break down. So we can, from this statement, we can say breakdown is 0.1. Probability of not breakdown, you can say B bar is actually 1 minus 0.1, which is 0.9. That's not breakdown. Probability of breaking down plus probability of not breaking down is equals to 1. Right, next, if a firm has 2 such machines which are installed at the same time, find the probability that at the end of the first month, just one is broken down. Assume that the performance of the 2 machines are independent. If they are classified as independent, what it means is A and B cannot break down at the same time. So it's either A or machine B, right? So A can break down while B is working, or B can break down while A is working. So 2 machines, machine 1 and machine 2, or machine A and machine B, whichever way. So let me call these machines M1 and M2. So machine 1 is M1, machine 2 is M2. So if they say find the probability that at the end of the first month just one is broken down, so it's either machine 1 will be working and machine 2 will break down, not working, M bar, or machine 2 will be working and machine 1 break down. Right, this one, if we can simplify this, it will be probability of machine 1, machine 2 not working, plus probability of machine 1 not working, machine 2 working, which is equals to, right, this one, machine 1 working, machine 2 not working. This probability is for both machine 1 and machine 2 not working, which means probability of machine 1 working 0.1. Probability of machine 1 not working is 0.9. Then probability of machine 2 working is 0.1. Probability of machine 2 not working is 0.9. So it applies to both machines, right? So machine 1, it will be 0.1 times machine 2 not working is 0.9 plus machine 1 not working is 0.9 times machine 2 working 0.1. Simplifying this, you can get 0.1 times 0.9 is 0.09 plus 0.09, which is equals to 0.18. 0.18. So this one is your final answer. Next question. Right, question number 8. 2 ordinary fair dice, one red and one blue, are to be rolled once. Find the probability of the following events. Event A, the number showing on the red die will be a 5 or a 6. Event B, the total of the numbers showing on the 2 dice will be 7. Event C, the total of the numbers showing on the 2 dice will be 8. So first part, we want to write down these probabilities. These are 2 ordinary fair dice, right? Ordinary die is 6 sides. It's a red and a blue die. So you have to draw the probability space diagram like this one. This one is, you can call it a red die, and this one is a blue die. Red die, how many sides? 1, 2, 3, 4, 5, 6. Red, the other die, blue one, also 6. 1, 2, 3, 4, 5, 6. And these events, are they based on totals or products? Showing a 5 total. So these are the totals. Yes, totals. Right, so you have to add all these numbers to find the totals. You can get a 1 on the red die and a 1 on the blue die. It will be 1 plus 1. It will be 2. So it's 2, then 2 plus 1, 3. 3 plus 1, 4. 5, 6, 7. Then here, 2 plus 1, 3. 4, 2 plus 2, 4. Then 3 plus 2, 5, 6, 7, 8. So it's more like it's flowing, right? And in this part, it will be 4, 5, 6, 7, 8, 9. This part 5, 6, 7, 8, 9. Then 10. This part 6, 7, 8, 9, 10, 11. This part 7, 8, 9, 10, 11, and 12. So these are the sum of the totals, die red and die blue. Right, then want to list, find the probabilities of the following events. Event A, the number showing on the die, red die, will be a 5 or a 6. Right, red die, it can be a 5 or a 6, which means if I am to use my item here, red die is this one, 5 or 6 is this part. That's a 5 or 6 on the red die. So it will be 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it will be 12 over first part, so it's 12 over 36. In total, it's 6 by 6, right? So it's 36, 1 over 3. Then next, event B, the total of the numbers showing on the dice, on the 2 dice will be 7. Total is 7. This one is event A. Then total is 7. Let me represent that by event B. Let me use this ink. Total is what? Total is 7. Total 7. total is, yes, 7, so it will be like this. So that's the probability that the total is 7. So that part B, it will be, total is 7 will be, how many 7s do we have here? 1, 2, 3, 4, 5, 6. So it's 6 over 36, which is equals to 1 over 6. Then part C, event C is here. The total of the numbers showing on the two dice will be 8. Total is 8, is this one. That's the line. How many 8 do we have? 1, 2, 3, 4, 5. So it's 5 over 36. Then done. These are the probabilities of these events. Then part B, state with a reason which two events A, B, and C are mutually exclusive. These are events which cannot happen at the same time. Like in this case, you can see there is no intersection on sum 7 and sum 8. This one was event C. This one was event B. Take note. So event B and C have no intersection, which means B and C, they are mutually exclusive events. So item B, B and C, no intersection, which means probability of B intersection C is actually equals to 0. Then next, show that the events A and B are independent. A and B is what? The number showing on the red die will be a 5 or a 6. We've calculated it here as 1 over 3. So A and B, if you want to show that event A and B are independent, we say probability of A intersection B must be equal to probability of A times probability of B. That's part C. Right, A intersection B, we come up here, A and B, we have 7 and 7 here. These are the two numbers, right? This one and this one. How many numbers is actually true over 36? That's A intersection B, true over 36. Then must be the same as probability of A times probability of B. Probability of A is 1 over 3 times probability of B is 1 over 6. 1 over 6 is here, up here, right? A is this one, 1/3, and B is 1 over 6 up here. Then if you can simplify this one will get 1 over 18 is equals to, then on this side is 1 over 18. So since they are the same, then event A and B are said to be independent events. Right. Then we can say done. Say Mangea, the Eagle, signing out. Subscribe, like the video, share this nice, powerful video. Thank you.